Hi students, welcome back to my channel once again. We are looking today at heat capacity. Now, when we say heat capacity, let's say you have a metal, all right, and the metal's temperature is, let's say, at 20 degrees Celsius. Now, what heat energy, okay, what heat energy do I need to change this metal from 20 degrees Celsius to, let's say, 21 degrees Celsius? That amount of heat energy is what we call the heat capacity. Are you getting it? Or let's say you have a hot object, okay? Let's say a hot metal. You can also use the same scenario for from hot to cold. So let's say a hot object is at, let's say, 10 degrees Celsius, and you want to put it in water so that you cool it to, let's say, 9 degrees Celsius. So what amount of energy do I require to change this temperature from the 10 to 9 degrees Celsius? That amount of heat is what we call the heat capacity. Right. So we are saying is the what? Quantity of heat energy needed to change the temperature of a body by either 1 degree Celsius. There should be a Celsius here. 1 degree Celsius or 1 Kelvin. So from the definition, then it is given by, normally we denote heat capacity by capital C. So heat capacity is given by quantity of heat energy. So you can also say amount of heat energy over change in temperature. We are denoting theta by as a change in temperature. So anywhere you see theta in this expression, we are referring to change in temperature. Some books may use delta T. Some people can use delta theta, or they are all the same, but it's just a convention. We are using theta as change in temperature for simplicity sake. So let's take note of that. Now, from the formula, then it means we can look at the SI unit of heat capacity. We can get the SI unit from the formula. The unit of heat is a form of energy, so it's joule, all right? And the change in temperature is still temperature. So it's joule per this. This is the unit, this, or you can talk about this or this. Now, why do we have these units? Let me go to the next page and show you why we are saying the unit of heat capacity is any of these four expressions. So let's deduce it here. What are we saying? We are saying heat capacity. Let me use the symbols instead of writing for us to move faster. Okay, we are saying capital C is equal to what? Q over what? Theta. We say Q is for what? Heat energy, right? And it's joule. Okay, heat energy. We are using Q for quantity of heat and theta for change in temperature. And we all know that temperature is expressed in degrees Celsius. Okay, so you get what? Joule per degree Celsius. Another way you can also express it, you can also use the Kelvin. That is the absolute scale. If you are using the absolute scale, then the temperature will not be degrees Celsius, but it's going to be Kelvin. Okay, so we have joule per Kelvin. So this is given as the second one, the first one, the second one. All right. You can even rewrite this as joule per this way, or you can even call it this way according to indices, right? Now let's look at the other one. Let's take the first one, Q over theta. We know that joule, okay, this one, the basic SI of joule is kilogram meter squared per second squared. Okay, why am I saying that? Joule is work or energy, and it's force times distance. force is newtons, distance is meters, and this newton is expressed as kilogram meter per second squared times meters. So this gives you kilogram meter squared per second squared. So this one is the basic SI of Joule. All right. So I can fix this one here. As you can see, I have done there. All right. And when I simplify this, I end up getting kilogram meter squared. Kilogram meter squared S neg 2 per degree Celsius. Per degree Celsius. So per degree Celsius. You can rewrite this as kilogram meter squared S squared. You can do this one too. This one is also accepted. Okay. Any of them. So this one has brought us to there. Okay. This one that I wrote is the one I've shown you here. Okay, then the same principle, the last one also holds for, here we are using Joule over Watt Kelvin. And if you are using Joule out of Kelvin, it means kilogram meter squared S neg 2 over Kelvin. And you end up getting what? Kilogram meter squared S neg 2 per Kelvin. Or you can even rewrite this as a kilogram meter squared slash. So I hope you get it now. That is why we are saying any of this, we've landed at this. So any of this gives you the SI unit of heat capacity. But in calculation, usually the one they like using is this one. But don't forget that we can also express the units in the way I have shown you. Thank you. Let's move on. Now I want you to, because we are talking about temperature change, okay, we talked about heat capacity being the ratio of amount of heat to change in temperature. I want us to note this fact about change in temperature. Temperature is a scalar quantity. So when you find it change, you have to get positive answer. Scalar quantities take absolute values. They take positive values, okay? So anytime you are finding temperature change, always remember that it is the bigger temperature minus the smaller temperature. You don't find change in temperature and get negative. Take note of that. That is what we have on this page for you. All right. Now let's talk about the last thing. When they give you a value of heat capacity, what does it mean? So we are looking at the explanation of the value of heat capacity. For example, let me reiterate. We have said that heat capacity, okay, is what? Q over theta. And this Q is what? Heat energy, right? This one is heat energy, and this one is what? Temperature change. Okay. So for example, if I tell you that the heat capacity of a metal is this value, 2.2 times 10 exponent 3 joule per Kelvin, what does it mean? It means that if you take the metal, let me change my pen. If you take the metal, okay, and it can change in temperature, can either be through heating or cooling, and you heat it or you cool it through this temperature, then the amount of heat you should get is this. That is the meaning. Because if you are given 2.2, what it means is that it means 2.2 times 10 exponent 3 joules over. This is the meaning of 1 Kelvin. The meaning of this is this. So it means that if I take, okay, it means that if I take the metal and I either heat it or I cool it through this 1 Kelvin temperature, then the amount of heat I need to use to do that is this 2.2 times 10 exponent 3 joule. Great. If you understand this, then can you try this one for me? If I say a certain alloy has this heat capacity, what does it mean? Try it and let me hear your comments. Let me hear your answers in the comments. Thank you and see you in our next